No, you want to do it?
Okay.
I'm trying
So
to do
as
my,
Mr.
actually my work
Johnson said, concentration of protons, which is also called H plus, is what again?
10 to the negative pH.
Okay, equals 10 to the negative pH. What's our pH?
9.259.
9.259. So how do we do that, guys?
10 to negative 9.259.
Right, so you can use the x to the y key. X to the y key. Correct? So, plug in your calculator. Put 10. You have an x to the y key. That will give you an exponent, correct? Then, 9.259. Make sure it's negative. Anybody have an idea what you get?
5.05.
5.5
Times 10 to the negative 10. And what's our unit?
Molarity. Big M.
Big M. Yeah. Is it easier to calculate pOH first or hydroxide ion concentration?
pOH first.
Okay, so let's try pOH first. Right? How do we calculate pOH?
14 minus pOH.
1.0 times 10 to the negative 14.
We can definitely do that, Mr. Everett. But, so Mr. Prayer and Mr. Johnson are electing to do it the easy way.
There you go, Dick.
14 minus pH. So what's 14 minus 9.259?
4.741.
Okay? Gives you 4.741. So that's our pOH. Now,
What's our pH though?
Right there.
gentlemen, give me your attention.
You got
Now,
specific.
how do we calculate OH concentration?
10 to the negative pOH.
Okay? 10 to the negative pOH. We can also do what Mr. Everett suggested, which was to take the 1 times 10 to the negative 14 and divide by this number. But let's go ahead and do the negative pOH, okay? Let's do 10, x to the y, 4.741 negative. Boom! What do we get?
1.816.
We got to round up. 10 to the negative 5.
I wasn't done.
Okay? So, this is essentially how to do the first side of your exam.
I feel.
Right? Because if you got one piece of information, you can calculate the other 3 very easily using one of 2 methods. So, what is the one method? You can use this. You can use the logarithm. You can use a KEQ, which is K of water, equals 1.0 times 10 to the negative 14, and you can kind of expand this O sort of indefinitely, depending on how many
That's 10 to the negative pOH.
Okay? Any questions about that?
Yeah.
Okay, we got a yeah.
Nah, I just want to know what that top part is.
This is the K of water. So the K of water is if you pretend that you have H plus OH minus.
What's that, Jay?
This is actually equal to the H plus concentration multiplied by the OH minus concentration. That's what that is. So that's what K of water is. Good question, sir. Any other questions about how we do this? Because the first part of it was fairly easy. Yes, sir.
On the first side of the test, I found the H plus.
Yes.
So I did a 1.0 times 10 to the negative 14 divided by H.
Hold on, guys. Got to listen to Mr. Mangum.
Okay.
Continue, please, sir.
I did the 1.0 times 10 to the negative 14 divided over H plus. It gave me the right number, but it gave me the wrong exponent.
Okay, so if it gave you the wrong exponent, there are 2 things that could have happened. One is you forgot to put a negative on the exponent. The other is you entered the second exponent wrong. Okay, so if you come on up, Mr. Mangum. All right? Let's start with this guy. So we know we got 1.0 times 10 to the negative 14 divided by our pH, which is 5.508 times 10 to the negative 10, correct? Okay, that is how you find the OH minus concentration, because if you want to solve for H plus, you got to divide both sides by OH minus, yes? Okay, so now, what you do is 1E14 minus, divided by your 5.508 exponent, 10 minus, you should have gotten that. Okay, so you got to make sure your exponent is negative. Not the number itself, but the exponent has to be negative. The exponent. Okay, so on your calculator, guys, you got to make sure, am I using a stack function or am I using a Q function? If you're using a stack, you're doing first in, last out. If you're using a Q, it basically reads it exactly as you punch it in, all right? Any questions about this? We have approximately 15 minutes left. I'm going to erase this, and we're going to go to the backside problem. Okay? Let's go to the backside problem. Mr. Thomas, you could shut that down, and I'll take my phone back.